been at the Medical College of Wisconsin now for just a little over 2 years, running my own independent lab in the Department of Surgery. But backing up, I'm from rural Oregon. I grew up on a farm with commercial agriculture, some animals, that kind of life. First generation college, so my older sister was the first one to really kind of go in the route of going to college and beyond. I just became so fascinated with science, just every aspect of science, particularly biology, but I also enjoyed, chemistry and physics, and just knew early that this was something I wanted to do with my life, and just continuing trying to understand everything about the world around us. I did go to college in Oregon at a small liberal arts school called Willamette University, and there I just had kind of really tremendous opportunity to get into a lab early on, and that solidified my love of science and really being an active researcher. So I did a dual degree there. I got a degree in biology with a minor in chemistry, and a degree in religious studies with a minor in classical studies. The reason for that, I just think that the community around you, especially whether it be the immediate community around you, or even the greater community, meaning like, let's say you're a part of a religion or like a political group, anything like that, all of that influences how you view the world around you, and especially how the role of science in that view of the world around you. So our lab, we're cancer biologists. We have kind of two facets of our research program. I would say the majority of my lab studies pancreas cancer and how it spreads to other organs, which is a process called metastasis. And the reason we study that is, unfortunately, still a very, very deadly disease. The 5-year survival rate is around 12%. You hear a lot of unfortunate stories of people being diagnosed and unfortunately succumbing to their disease in a couple months. So that's still a huge, huge problem. What's really particularly intriguing to me, and also very in a sad way, I should say, is that even the patients who have the best prognosis, meaning they have localized, early stage, surgically resectable disease, they usually undergo months of treatment followed by a very challenging surgery. And 1/3 of those patients will develop metastases in just under a year, often within a couple months. And then about 1/3 of them actually do very well. Mm-hmm. And right now we really don't know why patients fit into those two categories. So we really want to know, can we identify who is that patient cohort at high risk, or the patient cohort that's going to do really well, and then not only can we identify them, but can we develop new therapies that'll help kind of intervene or prevent that metastatic recurrence very shortly after surgery. And then the other aspect is we also study breast cancer. And what we're interested in is a type of breast cancer called triple negative breast cancer, or TNBC. And that's defined by a lack of expression of hormone receptors. Now, if you have hormone receptor positive breast cancer, there's quite effective treatments available. And in fact, if you're ER positive, the 10-year survival rate is like 92%. There's, very good prognosis. But this triple negative cohort, there's not a ton of great therapies. And so unfortunately, outcomes are very poor in that group. But one thing we do know is triple negative breast cancer is not one type of disease. It's actually quite heterogeneous, and there's subgroups within it. And we know if you're a subgroup that's kind of more luminal, we call it more luminal, your outcomes are better than if you're more basal. So those are two subtypes within TNBC. And so we want to know what makes a TNBC tumor more luminal and what makes it more basal, kind of the molecular underpinnings of that. But then beyond that, can we push a basal tumor more luminal and that make them more responsive to chemotherapy and less metastatic? I get that question a lot, and I never have a good answer. It was one of those things, and I probably imagine you're in the same boat. You just intrinsically loved learning about anything, right? About the world. Like, you ever, you have these like, I wonder why questions, and then it's either known or not known. Yeah. And then if it's not known, holy crap, why don't we know that? You know, and then,
Yeah.
and then like, can we go figure it out? I already knew I loved science, and then in middle school I had a really great biology teacher, Mr. Miller. And I don't remember his first name right now, but anyway, he was like energetic and excited, and then would get us into that science Olympics team I was telling you about, and so that just solidified my desire to learn throughout my life. I just want to keep learning. Now, that being said, my journey to where I am now was not straightforward. Because of my agriculture background, my first experience was in agricultural research. I worked at this research center in Central Oregon, and at the time the goal was to work on something called no-burn Kentucky bluegrass, and a fungus that grows on garlic called white rot. White rot's very bad. If your field gets white rot, you have to turn the garlic into essentially powder. You can't sell it as fresh garlic. And then Kentucky bluegrass is burning. The reason they burn in between seasons to maintain kind of high production of the Kentucky bluegrass, but the problem with that is obviously the environmental impact of burning fields. So that was very interesting, but maybe not my true passion. And then I moved to working at Nunnams, which is, they're like a seed production. They do a lot of genetically engineered foods, and we were trying to optimize umami in tomatoes. But anyway, I knew from that, I was like, okay, this is all very interesting, but not. And so then when I was an undergrad, I got into the lab of Jason Duncan at Willamette University, and we were studying axon transport. So axon are these very long cells that can run, for us, the length of your leg, for example. And it's one cell, so how does something move material from one end of the cell to the other when it's that long? That was when I was like, oh my gosh, this is just so much fun. Just really uncovering new information that nobody else in the world knows, and then that moment when you make a discovery that you are the only person in the world that knows it. So from there, because I was kind of already in the world of neurobiology-ish adjacent, I decided to join a lab for 2 years after my undergrad. This was Dr. Delev Boysen's lab in Portland, Oregon, and we were studying adenosine signaling. It's involved in ATP production, for example. Mm-hmm. But adenosine signaling in the brain in model systems of schizophrenia and epilepsy and traumatic brain injury. Mm-hmm. So during these diseases, let's say you have a traumatic brain injury event, there's a huge adenosine surge, and that adenosine surge can actually lead to brain scarring called astrogliosis. We were interested in trying to understand the balance of adenosine in the brain, why the surge causes disease, can we block the disease causing impacts of that. So anyway, that put me to maybe 24 at the time. I had all this research background in neuro, but I had decided I wanted to switch when I went to my PhD. I started my PhD program at University of California, San Diego. I thought I wanted to study maybe obesity and diabetes. I was interested in something called brown fat at the time. But when I started my PhD, I had decided I'm going to switch away from neuroscience, but I didn't want to study immunology, and I didn't want to study cancer. And then I joined a cancer lab that works on leukemia. So I broke all the rules, really. But I really liked that lab environment. I became very, very obsessed with pancreas cancer at the time. And even though this lab mostly studied leukemia, they had a small sect of people studying pancreas cancer and colon cancer, and that's who I worked with at that time. The lab was Dr. Tanish Dareya. She's very well known in normal hematopoiesis, but then got into leukemia and did a lot of work in that space. So anyway, that's how I got into cancer research and my love for pancreas cancer, which subsequently spread into breast cancer during my postdoc with Dr. Jeff Wall at the Salk Institute, and he taught me a lot about breast cancer and the challenges with breast cancer. That's a tough question. Science is such a long process that getting to this final, let's say, manuscript that gets published or something, it's just such it takes years to get to the end. So a single moment's always tough to nail down. And by the time you publish a paper, you're so exhausted with that story that you're just like, oh, at least it's done now, and I know, moving on to the next task and discovery. But I always tell people, this was actually a comment from a friend that I'm very proud of. This friend who I worked with at the Salk Institute, she at one point, we worked together periodically off and on over the years, and at one point she looked at me and she goes, you know how I know you're a good scientist? I said, how? She goes, you have so much negative data. And what she meant by that was, I don't try to ever manipulate data in a way to make it seem better than it is. To me, I'm just like, here's the data. My hypothesis was wrong. I think it's important that we know my hypothesis was wrong, and then let's move on to a new hypothesis. There's unfortunately a lot of people who don't want to let go of their hypothesis. They really want to believe that to the end, and I don't think that's productive. I think there's a lot to do, and we just need to know, like, okay, right, that I was wrong there. This drug, this gene, whatever, didn't have much of an impact in the disease, so let's move on. Yeah.
So what are some roadblocks that you face to get to where you are right now?
I think that I'm lucky enough to not have had a ton of major roadblocks. Not that everything went as smoothly as I envisioned, but more like as I always tried to make the most of where I was along the way, if that makes sense. So I had visions of doing my undergrad degree in some schools in California, but it's a long story, but I broke my arm very badly and lost some scholarships. Didn't quite financially have it together to go to schools in California. And then luck would have it, I had a full scholarship to this, small liberal arts school in Oregon. I was very upset that I had to go to, in my mind I wanted something different. But then that turned out so amazing. I just had this amazing opportunity to learn from Jason Duncan on, how to do molecular biology and cloning. And, it really set the stage for the lab in Portland, which taught me, modeling and rodents, which, I rely on very heavily now. So these visions you may have, I mentioned, I didn't ever plan on joining a cancer research lab, and now that's all I think about. I even dream about it. So maybe I encourage people not to think of things as roadblocks, but maybe it didn't go exactly how you planned, but you just make the most of what you have in that moment, and really try and springboard off of opportunities. So I mentioned that some of the people along the way that really helped me, all those mentors I had, absolutely phenomenal people that just helped me get to where I am today. I always joke that I don't really watch TV or movies or anything like that, so Hollywood's not my thing, but I have science crushes, So, and oftentimes those science crushes are people who worked to show unexpected things in science that maybe were underappreciated at the time, if that makes sense. So I study, let's say in pancreas cancer, how it spreads to the liver. Very early on, let's say about maybe 2015 era, there was growing evidence that there's something called a pre-metastatic niche. Essentially, the state of the organ, not where the primary tumor is, but a distant organ, can change during disease progression in a way that forms a niche that's more receptive of metastasis. And this was very controversial at the time, and now it's pretty well accepted, and there's a lot of people working in the field. But I would say some of the people who did that very early work, Greg Beatty, Dave Lytle, there's a couple other, that field, it really drew me to that, and we now work in that space. So I would say that I am terrible about work-life balance, but only because I love my work. So trying to convince people that it's okay that I work as much as I do, they would be like, no, that's unhealthy, but I find joy in it. Let's see, now to put a spin on it, to not scare people away from my field. My sister, her name's Nikki Lytle, she's at the Mayo Clinic, and she is a scientist there. She has a kid. She has a very successful art part of her life. So she does a lot of stitching and very creative, and has a lot of followers that follow her art. So anyway, she's like the most well-rounded human ever, and I'm just like, how are you also this successful scientist? There's that side, you know. Now me, I love like sports and dogs and being as active as possible, but ultimately I don't mind working weekends and nights. So anyway, I think there's a balance for everybody, and it doesn't have to be the same. I just love learning. Obviously, I do that for my profession and my lab. You know, outside of that, actually, this might be on the work life. I don't know if you can consider it that. I'm a huge podcast consumer. I'm currently listening to a podcast on realtors and the National Association of Realty. You know, it's actually really interesting. You know, what's going on with the National Association. Anyway, so the point is like I just want to gain information about everything. I just find it interesting to learn about everything, down to how a cell functions, and all the way to why is the National Association of Realtors such a mess right now. So, you know, continued learning. Yeah, I think, you know, a big part is reading current literature and going to conferences. That's truly how we stay up in our field at all times. But I learn a lot also from my lab. So my lab right now consists of, I have one postdoctoral fellow, a couple of PhD students, a technician, an undergrad student, a couple of med students who are volunteering, and they all have insights, and they all have creativity that can be used to approach problems in ways that maybe I don't see, and I cannot tell you how much I learned from them. I really love my lab. They're all hungry to do things in science, and that feeds into my learning as well. And then on top of that, I have fantastic colleagues and mentors at the Medical College of Wisconsin too. Good friends, like for example, Tommy McFall, who I talk to every day. You know, he studies an entirely different part of science than I do, and so I can learn from him all the time. And then the clinical side, Dr. Doug Evans, he's the chair of the Department of Surgery that I'm in. He has just these insights all the time into pancreas cancer. Every time I talk to him, he makes a note. He's like, I had a patient the other day that, and I'm just like, what? You know, wait, why? How come we don't know about that? You know, also medical oncologists and radiation oncologists like Mandana Kamgar, Bill Hall. I learn from them all the time as well, because they're treating people, and so they make these observations that we don't know why a patient responds in the way they do or don't respond, and so I use those observations to learn and try and bring them into my lab as well. The thing that I like to think a lot about in cancer biology is, let's take both initiation and metastasis. They're extremely rare events, and we know this now because they've done sequencing of people without cancer, and it turns out that we have lots and lots of cells in us, even starting as early as 30, probably even younger, but you know, they haven't gone earlier than that, where we have lots of cells with tumor initiating mutations in the tissues that should make a tumor with that tumor initiating mutation. And what happens is it'll create these tiny little clonal outgrowths. It should be cancer, but it's not. It sits there as pre-cancer for decades. Our body is very, very good at preventing that from becoming cancer, even though it should. For decades, we thought that tumor-initiating mutations were kind of the driver of cancer. But now we know it's not sufficient. There has to be something else that triggers that pre-cancer to go. And then same thing on the metastasis side. Patients, even in the earliest stage of cancer, actually even there's evidence in pre-cancer, that cells are already spreading to distant organs. And in fact, you can take a patient with stage 1 cancer and take a liquid biopsy, like peripheral blood out of them, look for circulating tumor cells, and you can find tens of circulating tumor cells in just a couple mils of blood. And if you think about how much blood is in a person, that could equate to thousands of circulating tumor cells at a given point in time. So there's lots of circulating tumor cells, yet patients don't develop thousands of metastases, they only develop a couple. So that tells us that, again, the seeding of a new metastasis is a very rare event. Our body is very good at preventing it. So if we know now that mutations are not sufficient to drive cancer, what else makes cancer happen?
Mm-hmm.
And then if we know that cells in circulation that spread to distant organs is not sufficient to drive metastasis, what else makes a metastasis? So these big questions are entirely black boxes right now. So one issue is we don't have the technologies to actually be able to understand this. We're getting closer. We have tools such as what's called barcoding. So you can imagine that every cell in a tissue you're studying is barcoded with a unique barcode that lets you track that cell, how it contributes to disease, okay? But the problem is let's say you barcode the entire pancreas, okay? Then wait until that pancreas forms a tumor, and then you look at the barcodes within the tumor. That doesn't tell you about the original state of the cell. So we don't have a way of capturing that original state of the cell that made that cancer happen. So we're trying to understand cell states at various points in tumor initiation, and then not only that, but who those cells are communicating with. So there's these technologies out there where when two cells are near each other or come in contact, it passes, let's say, a fluorophore, a fluorescent protein, or a biotin tag or something like that, from the cell you're studying to the cell that's next to it. So that lets us kind of understand cell-cell communication, but again, only at certain snapshots in time. So our lab is really working on developing technologies where not only can you pass the barcode or the fluorophore, but you can kind of set a timer where now, as that cell contributes to the tumor progression, there's a molecular timer or molecular clock, which will enable us to understand when it communicated. But it kind of captures the whole history of that process. Does that make sense?
Yeah.
Yeah. So instead of a snapshot in time, you're writing the book about how a cancer happened.
Mm-hmm.
At least in the field that we're in,
Mm-hmm.
most labs are, essentially doing the work within their lab, and that's why I have this team that, works on, let's say, this technology I just described. But that being said, I of course am relying on decades of literature of wonderful folks, across the world that have come up with very creative ideas and implemented those creative ideas, and then essentially I learn from that, or sometimes use that to continue to advance this technology I was just describing. And then in addition to that, of course I work with all the amazing scientists around me to bounce ideas off of them, and sometimes they'll give me a really key idea that I didn't quite get to yet on my own, that I'm just like, oh my gosh, that's such a smart way to, and then I immediately go. So it's very team science oriented. Even though the work is being done in my lab, of course it's truly a huge community contributing to it. I would say that the history of a niche, or history of a microenvironment is really one thing we're working heavily on, but in terms of technology. But I would say we have all these other projects. I wouldn't call them technologies as much as more like understanding biological processes in cancer initiation or progression to metastasis. And those are also very exciting for me, because what we do is we work to identify drivers of those disease states, and then can we therapeutically intervene with that. And so we're on really the front of we are basic science, but translational in nature, because we're trying to identify new therapies that can go to the clinic. And where I'm situated at MCW really gives me opportunities for that, because there's ongoing clinical trials, in pancreas cancer in particular, aimed to stop metastasis in these early stage patients. And so as soon as I find something that I deem very promising, the clinical group could move it into patients. So really amazing opportunities there. So we have several projects that so far seem very promising, but of course we do everything in our power to test it in every way possible before saying I think this should go into people. I love that you guys asked this question, and it is so embarrassing because I would say my normal life, I'm very passionate about, being as eco-friendly as possible. I think you guys know our world is dark right now in terms of they just published, I believe it was 2023's warming, and it was just 2023, I believe, warmed by 0.2 degrees Celsius, which is about a decade of warming. And then of course we see this in all the climate disasters that are happening. So this is a tough one for me because in my life I pretty much exclusively wear used clothing and really just try to be as eco-friendly as possible. And then I go to work and we go through plastic like you would not believe. We have -80 freezers to store, very precious materials, and a single -80 takes the same power as a 4-bedroom household every day. I know. And so we don't have, science is just not moving in an eco-friendly direction, and I don't know what the answer is for that. Some of the companies are starting to come out with more eco-friendly packaging, but for plastics, so I don't quite know what the answer is for that. And I think, right now there's not a lot of effort towards addressing that, but I hope to see in, that gain in importance, especially as these disasters keep happening. I would say do not, hesitate to reach out to people in the fields that you are passionate about to learn more about it. I think that can help a lot. I also just, generally speaking, I like to remind people, a lot of people don't know this, that PhDs in most of the sciences are actually free and you get paid. Nobody told that to me until I was most of the way through my undergrad, and I was like, what? You mean it's free and you get paid? So I tell everybody that because if they think finance is a burden or is a barrier, it can be a barrier to your bachelor degree, but then if you can get into a PhD program, that's wonderful. I also do have wonderful women mentors in my life, and I think that's very important. So again, reach out to women in the fields that impassion you, and figure out how they got there, and then take all the advice you can.